What's the biggest or the longest you've ever captured data for? So has it been like a day? Is it a week? I mean, and then how big are those files?
There's a difference between capturing and analyzing. These 100 packets, I can't keep up with everything coming in. So, hey, all of you were captured at this time, boom. And then all of you were capturing this time, boom. I call that gulping, time stamping. We take that out of the picture. But also now that we have the mountain of data, now what are we looking at? So it just depends on what's the amount of data, what is the actual load that we're capturing, and how long will we get?
Everyone, it's David Bombal back with the amazing Chris Greer. Chris, great to have you back on the channel.
Great to be back, David. Thanks for having me.
So Chris, you're the guy I talked to about Wireshark, right? And you've taught me a lot and taught hundreds of thousands of other people stuff about Wireshark. Dude, Wireshark's a fantastic tool. But I got to ask you this question, real world versus like the labs and demos. Here I've got 100 gig QSFP28 and here I've got 25 gig SFP. I've also got some fiber cables, right? So in the real world, you're going to encounter these kind of things. So my big question to you, Chris, do you capture at these speeds and then use Wireshark to analyze that traffic? And I think you've mentioned it previously when we've spoken. You've done like these 8-hour 1 gig interface captures. But I mean, how on earth do you manage that amount of Wireshark traffic?
Yeah, that's a great question, David. Very practical because look, real world isn't just some lab where you have a single TCP conversation. A lot of times when we do our collaborations on your channel, you know, we're sharing a PCAP and it's been heavily filtered. And, you know, I've gone through all the work of finding the one thing and then we talk about that one thing. Real world though, real environment, walking into a data center or working with one of my clients that has any type of enterprise scale environment, there's a difference between capturing and analyzing.
Okay.
Right. So Wireshark as a tool shows you the contents of a PCAP. Within Wireshark, you have the blue fin, and that blue fin will let you capture. That's on the top left of the user interface. You can go up there, you can select an interface, you can hit capture, and that will activate the packet capture driver on whatever system you're running Wireshark on, and you can collect traffic with that driver. Now, that said, let me ask you this, David. The system that you are working on right now to do this video, is it a born and bred packet analysis machine that is custom built and designed for that purpose?
Of course not. It's like a Windows computer, or in this case, a Mac.
Right. So the design intent behind that machine was to let you record a YouTube video, let you check some emails, let you check the web, and so on. So it's not designed to do packet capture, but we can do packet capture with it. So this is where we get into capture limitations of capture devices. So something that I've done, and maybe we can link some of the in the description, some of the work I've done on my channel, just to demonstrate the capture limitations of a standard laptop. And what I've done is I've actually started a capture with Wireshark and I fire a bunch of traffic across the bow of that machine just to see how much it can actually capture of that data stream. And the results, let's just say, have been quite shocking, not in the best of ways. Because there's two things that I'm interested, David, when it comes to doing accurate packet capture. I don't want to just capture all the traffic. So if you send 100,000 packets at me, I want to capture all of them. But I also want to maintain the timing. So if there was very specific timing between all those packets, if the delta times between all those packets was very precise going across the network, I want the packet capture to accurately reflect that. Because a packet capture is my window into the issue. If the capture is not accurate, then how can my analysis be accurate? I'm relying on that capture point as my eyes and ears. So that said, it's very important that in high capacity, high throughput environments, that I use interfaces and capture hardware that has the ability to keep up with those higher data rates.
Chris, a lot of hackers have an everyday carry, and it's always interesting to see the tools that hackers, take to site if they're doing a penetration test or something. You do this every day. You go to customers or you help them with like packet analysis and troubleshooting. What's in your everyday carry? Do you have like an IOTA or other devices that you take with you on engagements?
Well, if I'm just a carpenter, I can just grab a hammer and I can walk in somewhere, right? Or I can just get a screwdriver and just, hope for the best. Or if I show up, and if you have a handyman show up at your house, he's got some real tools. Yep. Okay, what happened to your confidence level? Now this person has some gear and they're going to get to work. So in my backpack, I make sure that I have a tap. I make sure that I have a stream-to-disk hardware appliance, and that one is the one that we've been talking about or going to continue to talk about on this video, and that is the IOTA from Profitap. It allows me to do stream-to-disk packet capture at high data rates, and then it also on the back end helps me with my analysis. So yeah, I can build a house with an individual hammer, but boy, a nail gun can really help me get my job done faster. So it's not just about speed for me, but it's also helping my clients understand what happened. I'm very big into that. I just don't want to come and analyze an issue and leave. I want you to understand what happened so you can learn, and maybe the next time you'll catch it yourself. And the IOTA with Wireshark helped me to do that.
So it's Wireshark, IOTA, your laptop. Anything else?
Yeah, I bring a slew of cables. I got a couple little Wi-Fi interfaces just in case I need to be able to remotely manage something. And also, depending on the environment, I'll also bring Profitap. And what that does is it allows my laptop to do line rate packet capture, which natively it can't do. So that's in my backpack as well.
And I think it's important to highlight, right? You do this stuff day in and day out. I know you've done work for banks and government organizations and like huge scale businesses, right?
Yes, I have. So accuracy is very important. Even in the banking environment, like you mentioned, sometimes the nanosecond matters. So I need to be able to use capture gear that can handle that type of timestamping and accurately be able to show me what's really happening. Also, when I'm troubleshooting, there's tools that can make it easier on the analysis side as well, which we'll get to. But just speaking about the capture, because you mentioned those interfaces, it's very important that we get all the packets accurately timestamped.
So Chris, I got to ask the question, right? If I've got a laptop, 1 gig interface, which is what I've got here, and it's actually connected by USB, which is another whole story. But let's say I've got a 1 gig Ethernet interface and I'm running Wireshark. Am I capturing 1 gig? And what's the speed of capture? How much can I actually capture? Because you kind of alluded to it not being great.
Yeah, for sure. So the testing I've done, so I've set up a test environment where I have a traffic generator that does 1 gigabit per second reliably. And I know it's doing that. That's like a purpose-built traffic generation tool. And then I have that going through a tap that then is captured by a purpose-built packet capture device. So 2 hardware devices that I know and can trust are sending a gig and receiving a gig. And then what I do is I take that tap, that's where I put my packet capture device, like your laptop or my laptop. And it's been interesting to see how low I have to turn the volume of that traffic in order to accurately and reliably capture it. It's been a year or two since I've done this test with modern laptops, but as recently as 2023, I did it. And let's just say that to capture every single packet, I had to turn the volume of traffic down from 1 gig. And this is on a high-performance Mac machine. I had to go from 1 gig, and it's not Mac's fault, everybody. Windows did it too. And Linux and Ubuntu, pick it. Because it's the hardware. It's the hardware you're testing. Yeah. I had to turn the volume down to less than 500 megabits per second just to capture all the packets. Okay, now notice what I said. Just to capture the packets. But the timing was way off. So even though it was able to capture everything, what I noticed was the capture device was ingesting traffic. And what the capture driver tries to do is when it sees a packet, it tries to give it a timestamp. Like, you were captured now, you were captured now, you were captured now. But so much gets ingested at once, it's not able to keep up with everything. So what it does is it does like these batch timestamps. Like, these 100 packets, I can't keep up with everything coming in. So, hey, all of you were captured at this time, boom. And then all of you were capturing this time, boom. I call that gulping. It like gulps traffic in and time stamps. Like, because and you see it in the packet capture. Because what you'll do is you'll see, and maybe I can find an example to share. I'll see if I have one. But what you'll see is a packet, and then the delta times after it for the next 100 packets are all zeros. Wireshark is acting like all of those packets came in at the same time, when physically they didn't. They were serialized. They did come in one after the other, but the capture point wasn't able to accurately timestamp them.
So, I mean, Chris, I'm assuming people send you PCAPs, right? So how do you feel, or what's your response to receiving a PCAP that someone's captured perhaps with a laptop and sending it to you for analysis? Because I know people do this all the time.
Yeah, because a lot of environments don't have high performance stream to disk packet capture, nanosecond timing resolution. But for low throughput environments, if they're just capturing like, hey Chris, here's something I need help with, and it's just a web, here's a web browser and here's a basic application, real low throughput stuff, single user, they'll capture that, send it to me, and I'll be okay with that. But often, David, to your point, I get sent packet captures, and what I'll see in Wireshark is I see previous packet not captured, previous packet not captured, previous packet not captured. And what Wireshark is telling me is that, hey, I saw a gap in the TCP stream here, and I didn't see it. What I look for after that is, did I ever see a retransmission? Do I see duplicate acknowledgements? Do I have any indicators that the two endpoints actually perceived loss, or is this loss at the capture point? If it's lost at the capture point, well, then my radar goes up, right? Like, hang on a second. I'm being hired to fix something, but I don't have all the data I need to fix it.
You're flying blind, right?
Yeah, and well, flying with some blurriness. Yeah. You could still see quite a bit, even if you didn't capture every single packet at line speed. You can still go a long way with that, but it's just, what if some of those packets that went missing were the ones that I was looking for? Another thing that can be difficult, what if the timing that I told you about, this is very common. I get sent a packet capture and the timers are way off. Like, it's just, like the capture point is just ingesting data, and the timing, I can see like all these zeros. Basically, it's, I have a packet that gets a timestamp, and bunches of packets after it get the same timestamp. Right there, I know that the timestamping is inaccurate. So again, it's difficult to believe. I know, I call it dirty data. Yeah. It's like, I know that this was not an accurate representation of the actual traffic that happened on the network. So I gotta look at it through that lens and take it with a grain of salt. So
I got to ask you, Chris, because we've done this in more detail in another video, but like a hub, a switch. A lot of people, when I do any kind of Wireshark stuff, say we should just span ports. And then you actually introduced me to this device quite a while ago, and they sent me one. This is an IOTA, I believe. So this is a tap, I take it. And this is, big shout out to them for sponsoring this video, but this is the device that you said a few years ago that you actually use in the real world. Is that correct?
Absolutely. The IOTA is great. It's a wonderful product, and not just good products, but good people and actual useful stuff. So yes, the IOTA, and you had it in your hand just a moment ago. It is a tap. You can put it physically in line. It does 1 gig, 10 gig, 100 gig. Depending on the size of the device you have. And the cool thing is, you notice you probably have a little button on there, David. A little start button on the other side. There you go. Right there.
Oh, yep. I see one. Yep.
So you plug it in, power it up, put it in. That's a tap, and it's a hard drive, stream to disk hard drive. I think that one's a terabyte. And you literally hit the button, and bam, it starts to capture. And from there, we plug in the management interface on the other side. And then that's where we can do our digging. We can look at our actual packets that are running. That is going to go into the whole conversation about analysis, which in high capacity environments is a whole nother conversation. But let's just stay on capture for a minute. Go ahead, David.
Yeah, so you've got these, you can put an SFP in here, I take it. So you could put a fiber connection into this.
So where I like to use the IOTA, where I can, is either send it to a client, have them plug it in, and I can use it as my eyes and ears, or bring it myself to an environment to make sure I'm getting accurate timestamps, all the traffic, and also the assistance with the analysis.
So Chris, you mentioned analysis right now. So, it's one thing to capture the packets, but I think you've mentioned it as well, that needle in a haystack type thing. I don't know how you do it. You look at these Wireshark captures and it's like, there's just so much, it's overwhelming. And I can imagine people who are new to this. It's overwhelming to look at Wireshark. So, and that's just in a lab. So, in the real world, how on earth do you make sense of what's going on?
That's a great question, David. And that's part of, when you're working through things at the packet level, get ready to be initially overwhelmed. It's a mountain of traffic. And I think on other videos, and we can link one from my channel if we haven't done recently with you, but even setting up Wireshark, we can do long-term packet captures. We can do that. We can basically, when you go in and start a capture with Wireshark, that thing's going to run and run and run and run and run. It's not going to stop until basically either your system crashes or your hard drive fills, whichever happens first. It's not going to stop until you tell it to. So then you're going to have this mountain of data. You're going to have this huge packet capture. Now, for me, that doesn't work out very well because, one, Wireshark doesn't do a good job over a certain level. Like I like to draw the line around a gig, like a 1 gig PCAP, opening up the up.
That's a lot, yeah.
It is a lot, but like if you're capturing over an extended period of time, you fill that pretty quick.
Yeah.
Right, depending on the throughput. So like if I tell a customer, hey, let's capture your edge network, all of that traffic for a whole day, that's a lot of data. So for me, I try to chop it up into smaller congestible file sizes. So for me, I like working with 500 megabyte files, but if I have to, I go to a gig, that's fine. And then I can just carve it up further with T-Shark or with a command line tool if I need to. But then I hit another problem, because if I have a lot of those files, like David, I could show you how, and I can set this up with you, like to do a packet capture that's extended and then get to 1 gig in a single file, save that off. Now start another one, save that off, start another one, save that off. And you could have 1,000 of those things. And you could say, great, Chris, I got a terabyte of traffic. And then I go,
yeah,
because I know that in every single one of those files is tens of millions of packets. And I'm going to need to dig through and set filters and do some pretty advanced stuff to be able to find the stuff that you're interested in. So I'm going to have to use some T-Shark scripting. I'm going to have to do some real, Swiss Army knife stuff to be able to find those packets. And that it can be very difficult to teach, especially with newer Wireshark users, because it's so overwhelming. So that's where enter a product like IOTA. I heard another analyst say this recently. His name's Mike. And actually, I used to work for him. He's a fantastic analyst. He's one of the best that I know in the world. And he mentioned recently that you can move a mountain with a shovel if you have enough time.
Yeah.
Or you can get it done with the right tools. And the IOTA is one of those right tools. So not only does it help us to do all of the packet ingestion that we need and all of the packet accurate timestamping, we take that out of the picture, but also now that we have the mountain of data, now what are we looking at? And it gives us that fire alarm view where we can see the traffic over an extended period of time, and then we can begin to set quick filters, which David, then with 1 click, I can export stuff back out into Wireshark once I have a higher level view of what's going on. So if you're interested, we could take a look at the demo.
Yeah, I'd love to see it. I mean, it's one thing to talk about it, much more fun to see it. Because I've got to ask you this question. What's the biggest or the longest you've ever captured data for? So has it been like a day? Is it a week? I mean, and then how big are those files that you've had to work with?
I mean, for me, once I get into that level of capture, I want to do so with a product like the IOTA that can do, it's purpose built to do that.
Like a terabyte one.
Yeah, this one has a terabyte. But I've done up to a couple of weeks of data. And those aren't, 100 gig fully loaded links. You're talking about, those are smaller environments where we could do that. But that's not unreasonable to say, hey, we need to capture a day or two of traffic and see what's going on, especially when we're doing our forensics, our threat hunting, our analysis to see if there have been any compromises that the IDS, IPS systems have missed. So that's not uncommon to hear that. Like I mentioned, I really try to keep it consumable. When I'm capturing with Wireshark, I try to keep them 500 megabytes, 1 gig. So it just depends on what's the amount of data, what is the actual load that we're capturing, and how long will we get. That then just comes down to math. All right, David, so in my demo environment, and this is what you can see right here, this is just a Windows box that I've got, and I've got it connected to a switch, and then that switch goes to a tap or to the IOTA and then to the gateway. And this Windows box is basically the only thing in this lab environment. Then after that, it goes straight out to the internet. So anything that you see here is just literally like a Windows machine, very simple, connected out to the internet. So what I'm going to do is I actually have on this machine, I'm just going to head on out to YouTube, and I'm just going to look at this YouTuber guy that I know. And I'm just going to take a look at his channel. Wow, what a cool channel. And I know, man. So I'm just going to let this just run in the background, and maybe I'll also head out to wireshark.org and just do a couple other things. How about some weather? Okay. All right. So here's the IOTA, David.
Nice.
So let me just walk you through top to bottom a little bit about what you see here. So basically over here, we could see this is our bits per second. We got some traffic that happened, a little bit more running in. Over here, now this is the IOTA base page front screen. This is for the last 6 hours. I'm just going to change this to the last 15 minutes just so we have some recent stuff coming in. And over here, this is basically our conversation matrix. So the Windows machine that you just saw is right here. And I'm not too worried about everybody seeing all those other IP addresses, because guess what? You can see them too. There's none of that's internal. So it's all just going out to different YouTube servers and going out to Wireshark.org and so on. My internal machine is just this private address space, this 10 network here. And so I can see initially all the conversations that Windows machine has had. Now, if there's something real specific that I wanted to start to dig into, I just clicked on that IP address. And right now, what that did is it set a filter for just that machine's IP. So now I'm not looking at everything going across the IOTA, just the conversations to and from 4.16. So that's the first thing that I wanted to do. The next thing that I want to do, David, is I'm always very interested in the time that things happen. So if you tell me, hey, at 9:16, something got a little funny. Something looked a little weird, Chris. So could you help me out? Well, now that you give me a time context, I can come over here to my my bits per second, like this graph, and I literally can just do a swoop across that time index. And right there, I can go, okay, David, now I've got your IP address, and now I've got the when factor. So now I know all the conversations that David was having within that period of time. That is huge. Now from there, I can see I've got a handful of little conversations going on internally, but let's just say that I was able to identify this is the server that we were talking to, and check out this application that we have here. So YouTube. So let's just say you said, oh man, YouTube was just terrible. It was just choppy. It was bad. I mean, the content itself was amazing because we were looking at your channel, but let's just say performance was kind of junky. Well, right here, if I want to, David, I can come over here. You see this little download button right here? I'm just going to click that. And guess what I just did? I got my packets. So now if I want to, Wireshark Analyzer, baby, with 2 clicks and a swoop, I got to David's packets that I'm interested in. Now I can start to do my deep dive and do all my little Wiresharky things. And check this out with my delta time. You see my delta time right here, my timestamps?
Yeah.
This thing is getting timestamped to the microsecond right here. So that's pretty cool. What I wouldn't want to see, I mean, this one I'm not super worried about. It's just 1 packet, but what I would not want to see is a ton of zeros here, because then that means that in my delta time, the inter-packet gap is really not timestamped accurately. But here, the IOTA is doing it down to the nanosecond. All right, so that was just a very simple workflow. I clicked on an IP address. I zoomed into a time period. I saw a conversation down below, and I exported that to a packet capture, and I did it like this.
So, Chris, this is great. But, in the real world, if you were doing this with Wireshark, how much work would that be?
That would be quite a bit of work, David. I'd have to zero in on the right time index. I'd have to set a filter on that server, and then I would have to find that connection to YouTube. And yeah, that would take several steps to be able to find that single flow. But with the IOTA, I was able to do it.
And assuming that's in your one of your 500 meg files.
That's exactly it. Yeah. And then I'd have to find the right one first. And then did we even capture it? And then if we did capture it, did we capture it accurately? What if I open up that packet capture, David, and I see a bunch of missing packets and gaps and inaccurate timestamps? Right there, I got all kinds of questions. So that was just one basic flow with the IOTA. I'd like to do another one with you. So let's go ahead and back up. I'm just going to come up here and just say garbage on that filter. And I'm going to reset my time index. And I'm going to come in here and I'm just going to go back to the last 15 minutes. And I'm going to change over here to this navigate button. This is pretty interesting. Right in here, I'm just on my home screen, but this is where I can start to look with the IOTA to more specific things like, how about application overview? What application overview does is it shows me the applications that are in place over time. So here you can see this is just literally Windows. So I'm not surprised to see things like Microsoft services, Google shared services, Akamai Technologies, YouTube. So right here, my eye gets drawn to an application or a service that might not be the most healthy. So what do you think? Should we go dig into that one?
Yeah, it'd be great. Yeah.
Let's click that. And right there, automatically, a filter was set on that application. So now up on top, I can see the bits per second. I can see the enterprise services. If I want right here, I can go straight to download and I can export this packet capture if I really want to.
So Chris, just a dumb question, right? The IOTA is doing like a PCAP capture, is that right? So it's capturing as if it's like Wireshark, but it's giving you this analysis on top of it. Is that fair to say?
That's correct. So that device that you held up, that hard drive, it's doing stream to disk packet capture and collecting that into a packet data store. And then this analysis feature is allowing me to take a look at all of that traffic, not from a PCAP to PCAP to PCAP perspective, but like look at all of it. And now I can look at a flow and export that flow as a packet capture. And that's a huge advantage. Let me just say, if I'm doing this without a tool like the IOTA, let's just say, for example, you capture a full day's worth of traffic and you give me 100 1 gig files. Well, it could be that you start a conversation in one of those files and you end that conversation 3 files later. And I've got to go and I've got to filter all that out. And then I got to merge all of that together to create a single flow that spanned several different packet captures. Well, IOTA that doesn't matter. It's all the same packet repository. I'll just call it that. And then it sees over that whole data set and then lets us filter in clickable interface. And even here, client servers. So I can take a look, if I expand out, I can see, the client IP, the services that we're talking to. I can come down and look at the different host names that I'm communicating with, the different server IPs, and all of this is clickable. So as I drive, the IOTA is building the picture for me in a real natural way. What do you want to see? When do you want to see it? And then do you want to go to a single flow or single conversation and then click to export a packet capture if you just really got to go to that level, right? So very, very useful and drivable interface. So right now, I just clicked on a server that my machine is talking to. And right here, packets out. That's interesting. Bytes out, packets in, bytes in. All right, David. So from here, when I clicked on Microsoft Services, see, now I can go over here to latency. And what this is going to do is show me all those conversations that I'm having with these different servers. And it's going to show me the server latency. So how much time is it taking for that server to begin to talk to me? From there, I can drop down. I can see some more information. I can come in and I can click on one of those interfaces. And it's even showing me down below, it's showing me just a graphical representation of where in the world is that IP physically located. Grain of salt, right? It could be that, it's coming in from a different location. It's being spoofed. But generally speaking, that gives me a good idea. And as I come down here, so bandwidth by client IP, I can see the bandwidth and I can see, which server I'm talking to. There is one view that I'd really like to show you, and I'm going to back up a couple steps here. I'm just going to come back home. And what I'm interested in here is I want to show you, so I can see my applications over time, what applications are running, Quick, SSL, Total, YouTube. But you know that I'm a bit of a TCP nerd, right?
Yeah.
So it's nice to see top-down troubleshooting. I can click on an application, dig into that conversation, go into the flows. But I can also come up here and navigate, and it's got a very cool TCP analysis view. And this is one that I like to use. And right here, this is unfiltered. It's all those conversations that you saw, all those applications, which I can begin to filter if I'm interested in. I can filter for a specific app, specific IP. Let me set a manual filter here. I'm just going to do IP. And the value that I want to filter for is this host IP that we've been looking at here. So right there, I just reset everything. With 2 clicks, I said filter, the protocol, then the IP address, and it applies it. Shows me over the last 15 minutes. And now what I can see is IRTT, so initial round trip time, max latency, payload, duration, TCP events. So I can see, do I have any unanswered SYNs, incompleted 3-way handshakes, 0 windowing. If I come down further, bandwidth, latency, so I can see upload, download, what direction was stuff going, what were the applications that were in play. And at any time, David, I can, if I'm like, ooh, this is an interesting spike of data that I've got here, all I got to do is just swoop across it. And now all of those metrics are going to be reflected on that specific period of time that I just zoomed in on. So right here, I notice up in red, the other thing that the IOTA does is it looks for slowness for me. So it's got built-in metrics here where it's going to say, hey, IRTT looks like it was a little bit high. Hey, do you want to come in and check this out, Chris? So now what I could do is I can pivot and go, okay, this is a single TCP flow. Let's go ahead and take a closer look to see, like this, I'm just going to hit inspect over here. Now I'm taking a look at that specific connection with that specific server at that period of time and check out all the info that I get.
That's nice. Yeah.
Flow detail, client, server, TCP connection, SYN, SYNAC, ACK, data. I can see the number of packets. I can see the delays. I can see the server latency, round trip latency. I can even see the application, the TLS version, the handshake. I can see what was the cipher suite that was selected. So a ton of stuff. Now here I have a question. David, do you think that I really got to go to Wireshark at this point?
Well, I mean, I'm assuming you would, Chris, but I mean, I think for a lot of people, this is a lot of information. And what's nice about it is it's summarizing it nicely. So I don't know. What would you do?
Yeah, I think that's a great answer. I don't really need to.
Yeah.
Anything that I could think to want is here. If I really needed to, I could further export this. But let me just back up a screen. So here I went from, hey, Chris, what's wrong, to give me the period of time. Let me click on the client. Let me dig a little deeper into the application they're using. Now let me go to TCP and take a look at slow round trip times that IOTA is flagging for me. And then I can go deeper into actually inspect those flows. So back to your question about help with the analysis. Can I do all of this with Wireshark? Sure. Can I do it at line rate? Line rate 10 gig, extended period of time, back in time analysis. I can move a mountain with a shovel.
Chris, I'm assuming this is a product for professionals. And I'm assuming someone like you, the ROI for you buying a product like this has been many times over.
Oh, absolutely. Yeah. So now, not just am I saving time, but I'm also getting the accurate traffic that I know I need, right? If I'm a doctor and I've got a broken, stethoscope, or if how comfortable would you be if you came into surgery and I'm a doctor and I've got all these, dirty utensils and stuff? It's like, when you're doing real packet analysis and capture in today's high throughput environments, you just need better tools to be able to consume and analyze that traffic and be able to see all of this stuff. It used to be, David, years ago when I first started this, and speeds and feeds were, 10 megabit per second was the thing. I remember when fast Ethernet came out, 100 megabits per second. And then, now gig and beyond. As speeds and feeds has grown and applications have gotten more bandwidth hungry, and also encryption has increased, it's just gotten more and more difficult to do things on the wire with just Wireshark. So we've grown to this point where having some extra hardware behind what you are doing, it makes your analysis more thorough. It brings it into a greater speed and feed, gives you that real analysis. And then with the analytics like the IOTA, simply lets you select and pick and flow into what you're interested in. I've worked with several vendors over my career, David, and in different packet capture and analysis tools. And they have varying levels of how much can they capture, and can they do this over time, and can they do this at a certain throughput, and what's the stream to disk rate, like how many packets can they consume at 40 gigabits per second, 100 gigabits per second before they drop, with those types of things. But that's all great, But then if I have this mountain of data, I need help digging through it. And something that I appreciate about the IOTA versus other vendors I've worked with, I can help someone be effective very quickly with the IOTA.
I mean, the real testament to me is this is what you use day in and day out.
Yeah, absolutely. And then with the clients that I work with, everything that I just showed you, to me, it didn't take a lot of training to be able to use the interface, right? Here's a period of time. Here's a application I'm interested in. Here's a filter on David's IP address. Boom. That's very natural in the way it guides your analysis. Where sometimes, I'll get into a tool set that is great on the packet capture, but the analysis side is so cumbersome. It takes a superstar expert. I mean, there's a vendor, and I won't say who, but I have sat a full week of training to how to use their product, and I still was not able to use it at the end. And I'm like, this thing's just too hard to use. So the IOTA keeps it simple and shows you what it guides you to what you're already likely looking for.
That's great. I mean, Chris, I really appreciate you sharing, the real world stuff. And again, like I said, I remember you holding up an IOTA years ago, just when we were doing some random video, and telling me this is the product that you use. I really want to thank Profitap again for sponsoring this video, and for allowing Chris to share this kind of stuff, and also for sending me one so that I can learn how to do this.
There's a reason why Profitap is winning awards. You can just go to their website and you'll see they're winning best in class. They're winning awards over this tool. And I'm very passionate about it because, they're great people, great product, well supported. You can tell that this is an analyzer built by analysts. It's not just marketing. So I'm very passionate about it. Go check it out. The other thing about Profitap, David, is that it's not just for large footprint, high capacity environments. They have all that stuff. Packet brokers, huge TAPS arrays. You can get into the millions with this stuff. But it also has stuff for the smaller mom and pop IT environment. Like one of these IOTAs can do a great job in a smaller network. Or if you have an environment where you're supporting multiple offices. I was talking to one guy. He had several different schools that he was supporting. He has an IOTA at each school, and that all feeds into a central area where he can centrally manage all of that. So Profitap can adapt to your environment. It can appeal to a lot of different types of budgets, a lot of different types of footprints, a scale to smaller connections, much larger connections. And so they're really, to me, what I like about Profitap is there's just something for everybody. There's something for every budget. So definitely encourage everybody to go check them out.
Chris, as always, thanks so much for sharing your real world knowledge with all of us.